Okay, so what I have in front of me is the specification sheet for the LSM9DS0. Again, this is the sensor that we're going to be using ultimately, and we're going to go ahead and try to find in this specification sheet all the little different ways that you can actually communicate with this device. The first part, we're going to go ahead and figure out exactly how to get the data from the gyroscope and then change a few of the options that we want. So with that in mind, let's go ahead and start. So what I have over here on the right is a calculator, so a programmer's calculator, just in case if I actually need to figure out exactly what the bits and bytes mean. So say if I can actually manipulate the bits over here, I can actually figure out in decimal format what that means. I can also get the hexadecimal format if I need to, because sometimes they'll actually provide things in hexadecimal. And so let's go ahead and get started. Let's scroll down a bit. And if you haven't noticed yet, this thing is 74 pages long. So thankfully they provided a table of contents. So let's go ahead and scroll down here and figure out what we want to get. Okay, so some terminology, some functionalities of it, not too important. Application hints, okay, digital interfaces. So there's the I2C serial interface and SPI bus. We discussed this already, and I pretty much used this one just to explain how SPI works. But in some instances, it's important to look at their specific SPI interface because sometimes they have additional commands aside from read and write. Sometimes they have like universal commands like, turn off the device. They have this specific code that if you just send it to the device, it'll just turn everything off. Or like a universal reset button, effectively. Okay, so we have register mapping right here. So let's go ahead and go to the register mapping. Okay, so there's quite a lot. Again, this is like 3 sensors, so just expect to have a lot of registers. But thankfully, only the first page is the one that contains all the gyroscope registers, which you can actually notify it by seeing the underscore and G, which means gyroscope. All right, so let's go ahead and find a few of these things. You can see that it's called the whoami underscore G. This is like the ID register of the gyroscope, so it pretty much has a set ID, and if you can read from it and write from it, that pretty much means that you're actually able to communicate with the device. So let's go ahead and just record that. 0x0f is the hexadecimal value for the address. So if I type in F, that pretty much means it's a decimal format of 15. Another thing to recall is that when it comes to the actual like SPI communication protocol, the topmost bit indicates whether or not you actually read from it or write from it. So this means that this actually needs to be a 1, and then the address over here is the 0x0f, and this is the multiple read if you want to. But if you set to 0, it doesn't actually do the multiple reads. So we're going to set that to 0. So actually, our code is not going to be 0x0f, but actually 0x8f right here. So the actual code is 143. So the adjusted one is 0x8f, which equals to 143. So that's the code. That's the address to access it and read it. And if you scroll down over here to actually get to that place, okay, you'll see that it's 1101010. So let me go ahead and just put that in here. Let me clear this and just type in. Put in 1101010. So that's 212. So the address should be 212. Just go ahead and put that as a little document. It should be 212. All right, so with the control register 1, let's go ahead and look at this. Okay, so there's the output data selection that you can manipulate from the top 2 right here. So the top 2 over here, you can change the data rate, and they actually say refer to this table to actually set the data rate right here. So actually we can see over here that if I have the data rate as 0, I have the data rate as 95 hertz, and I can set this up to 760 hertz the sampling rate. So you can go ahead and figure that out. I guess what we're going to be using, we're just going to be using 95 hertz for our case. So that's going to be 2 zeros. I'm going to go ahead and clear this so I can figure out exactly what I want to have for this bit mapping. So these two parts the top 2 are going to be 0. Okay, the bandwidth selection, I don't think it's going to be too important for the bandwidth, so we're just going to set that to 0 as well. So the top 4 bits are going to be 0. Power down mode, okay, so we want to actually have it on, so we're going to set this to 1. So the 1, 2, 3, 4th bit is going to be 1. Alright, and then we want to actually enable the z-axis, the y-axis, and the x-axis. So we want to set all of these to 1 as well. So we're going to go ahead and put all these to 1 and figure out what that number is. Okay, so that's 15. So we want to actually say control register 1 for the gyroscope should set to 15. And again, since this is a write, this pretty much means that the address, which is 0x20 hex, that's what the H means. So if I go to hexadecimal and type in 20, that should be the number in decimal. So the address is 0x20. I don't have to change any other parts of this address because this is a write, so that means the topmost bit is going to be 0. I'm only going to write this to this once, so we're not going to be doing a multiple write. So it's just going to be 0x20 is what we're using, and the address is also called 32 in decimal format. Let's go ahead and scroll down here. Okay, that's just the, let's see, control register 2. Let's not, we don't want to put the high pass filter on this, just for the first part. Let's go ahead and skip that. But the idea of the high pass filter is what you can actually do is before you actually read out the data, you can set this high pass filter, and it'll help to make it so that any sort of like non-moving frequencies or every slow moving frequencies will be removed. We can probably set this later if we need to, but let's go ahead and first test if whether or not we actually need to do that. Okay, so these are just additional stuff for the interrupt, and there's this thing called this first in, first out register, which pretty much helps us store 32 data samples if you want to do that, but we're not going to be working on that, focused on that in particular. Okay, so block data update, by default it does a continuous update, so we don't have to worry about that. Alright, so the full scale selection, so you can send it to one of apparently 3 different options, so we can set it so that the maximum sensitivity of it is going to be a range from 245 degrees per second or 500 degrees per second or 2000 degrees per second. I think we're going to go ahead and set this to 500 degrees per second. So I'm going to go and say that we're going to set control register 4_G. The address is equal to 0x23. And let me go ahead and put that in decimal format. 0x23 is equal to 35. Alright, so we want to make it so this is FS1, FS0, so these are the 2 bits right here. We want to set it to 0, 1, so this is going to be 0, and then this is going to be 1. So it's going to be, let me go ahead and clear this. This is going to be 0, 0, 0, 1 right there. And then let's see if there's anything else we want to actually enable on this. So by default, it is the 4-wire interface. We don't need to change that, and that's the one that we're using for SPI. The self-test, we're not going to enable the self-test because it's not important for what we need to do. Okay, so that's actually going to be set to 16 is what we're going to be doing. Alright, let's see if there's anything else here that we actually want to use. This is kind of for the first in, first out register, and for the interrupts, again, we're not going to be using that stuff. We're just going to be focusing on just collecting data from the gyroscope. Alright, this is just an assortment of different things. It doesn't seem to be too important. Okay, here we go. There we go. This is important. So these are the 2 registers these are the registers that store the data and the ones that we're going to be reading out from. Okay, so we can see that 0x28 is the one that contains the low bytes. That's what the L means. And the 0x29 contains the high bytes. Because what's going to happen is we're going to get this as a 16-bit format, and each of these registers stores 8 bits. Let's go ahead and figure this out. So we want to read from out_x_L_G. The address is called 0x29. So 0x28. And then again, the topmost bit has to be 1 for us to read from it. Another thing to keep in mind is that what we can also do is we can also do the multiple read option. So the multiple read option pretty much means that we're going to first read this one, and then we're going to read this one second. So that actually makes it so that instead of calling this address, reading it from it, and then calling this address and reading from it, we can just go ahead and just call this one address and get these 2 at the same time. It just makes it a lot faster. So we're going to go ahead and set these 2 topmost bits to be 1, and we're going to actually get something called 0xe8. So let's just go ahead and write that down. 0xe8 is the adjusted one. This one should be 0x28 and 0x29 are the old ones. 0x28 and 0x29. This should be low high. Okay. All right. So 0xe8. Let's go ahead and convert that to decimal mode. So it's 232. And that's pretty much it for the X data. Let's go ahead and go check out the Y data. It's going to be pretty much the same thing. So I'm just going to go ahead and copy paste this and get this format out. This is to read X data, or at least the angular velocity around the X-axis. is the idea for the gyroscope. Okay, so this is the read Y data. All right, it's 0x2a, 0x2a. Again, we want to have the topmost bits over here. Whoops. 0x2a and 0x2b. You can see over here that if you need to set the topmost two bits to 1, so it can do the multiple read and make it read. So it's actually going to be 0xEA. If I go ahead and check that, it's going to be 234. All right, so now we're going to read the Z data. So again, let me just clarify that this is a multiple read. Multiple read. Just copy paste this. All right, so out Z low high. Okay, 0x2c is what it's going to be. 0x2c and 0x2d. And a multiple read therefore means, let me just type this in, so 2c, and then I want to set the topmost two bits to 1, that equals to EC, and in decimal format that means 236. All right, so I think that's pretty much it for the gyroscope. Unless I go ahead and scroll down and see if there's other options. Okay, this is the first in first out stuff, which we're not going to be using because it's just a means for the gyroscope to store 32 different. It's to store. It's just to hold some data so that if you're not reading from it continuously, you can read all 32 at once at one point in time, and then go ahead and wait until it fills up again. We're not going to be doing that. Okay, this is for the interrupts. This is also for the interrupt. This is also for the interrupt. This is also for the interrupt. All of these are for the interrupt. This is all for the interrupt. And okay, when we scroll down here, we can see these are going to be used for the accelerometer and the magnetometer. That's what XM means. So we're going to go ahead and stop here and just go ahead and write this stuff up into a little format so we can actually figure out how we're going to write the code up.